This video explains questions and answers regarding the experiments done to identify the elements in organic compounds. The first question: explain two experiments and their respective chemical reactions used to identify whether carbon and hydrogen are present in the given organic compound. Pass the product obtained by catalytic combustion of organic compound through anhydrous copper sulfate. Anhydrous copper sulfate is white in color. It is converted to hydrous copper sulfate, which is blue color, and water vapor is evolved. Therefore, it proves the presence of hydrogen. These are the chemical reactions for this experiment. In this reaction, water vapor is formed. The next reaction shows how anhydrous copper sulfate, which is white, is converted to hydrous copper sulfate, which is blue. In the next experiment, pass the product obtained by catalytic combustion of organic compound through colorless lime water solution. In this experiment, we can observe that the colorless lime water turns to milky color. Therefore, we can see that carbon dioxide is evolved. It proves the presence of carbon. These are the chemical reactions for this experiment. Calcium hydroxide is the chemical formula for colorless lime water solution. The second question: what is Lassaigne's fusion test, also known as sodium fusion test? It is a general test for the detection of elements like nitrogen, phosphorus, sulfur, or halogens in an organic compound. This is done by fusing the organic compound with sodium metal. The ionic compounds formed during the fusion are extracted in aqueous solution and can be detected by simple chemical tests. Third question: state the conversion of following elements present in organic compounds when reacted with sodium fusion extract or Lassaigne's extract. Nitrogen is converted to cyanide ions, phosphorus is converted to phosphate ions, sulfur is converted to sulfide ions, and halogens are converted to halide ions. Fourth question: why sodium is used in this Lassaigne's fusion test? There are two reasons for this. The first reason is sodium has a very high reactivity with most of the elements. The second reason is the sodium salt formed by reaction is highly water soluble. Fifth question: how to prepare the sodium fusion extract or Lassaigne's extract? If the organic compound is liquid or gaseous one, mix the compound with sodium carbonate and prepare a paste. Place the prepared sample or the solid organic compound in the bottom of a dry ignition tube. Then grab a piece of sodium gently and fix it in the middle of the ignition tube. Slant the tube and heat the sodium piece using a Bunsen flame until it is melted. When the sodium is completely melted, keep the tube vertically and let the sodium sample fall onto the organic sample and heat the mixture until it is red hot. Then put the heated ignition tube to a 500 milliliter beaker which is half filled with water. When the hot tube is immersed in water, it will explode in the beaker. To be safe from accidents, cover the beak with a wire mesh. Soon after, the tube is immersed in water. Then heat the water beaker with the tube for some time. When the beaker is heated enough, use a filter paper and filter the glass pieces and the waste material in the beaker. The filtrate obtained after filtering the waste is called as the Lassaigne extract. This diagram describes the above process. The next question. Explain the experiment used to identify the presence of nitrogen in the organic compound using Lassaigne extract and mention the chemical reactions of the experiment. If nitrogen is present in an organic compound, all the nitrogen will be converted to cyanide ions in the presence of Lassaigne extract. These are the chemical reactions for this experiment. According to the chemical reaction, sodium cyanide is formed. Prepare a Lassaigne extract to identify the presence of nitrogen. Add a few drops of freshly prepared ferrous sulfate solution to a small amount of the extract. Then add a small amount of ferric ions or heat the sample mixture in the tube, which converts the ferrous ions in the sample to ferric ions. Add a few drops of diluted sulfuric acid to make the medium acidic. The reason to acidify the medium is to remove the hydroxide ions in the extract, as the extra sodium present blocks the formation of Prussian blue color. The reason for the absence of Prussian blue color is when hydroxide ions are present, it forms a dirty green precipitate with ferrous ions and also forms a yellow-brown precipitate with ferric ions. Ferrous hydroxide is the dirty green precipitate and ferric hydroxide is the yellow-brown precipitate. The final observation of this experiment should be the formation of Prussian blue precipitate. Seventh question. What is the reason for obtaining a black color in the end products instead of Prussian blue color in the above experiment? If a black color is observed, the reason for it is the presence of sulfur in the organic compound other than nitrogen. The formation of ferrous sulfide gives the black color. Eighth question. What is the reason for obtaining a blood red color in the end products instead of Prussian blue precipitate in the above experiment? If blood red color is observed, the reason for it can be the presence of both nitrogen and sulfur in the organic compound. The thiocyanate ions formed react with ferric ions to form a blood red color complex called as the ferric thiocyanate. Ninth question. Explain the experiment used to identify presence of sulfur in the organic compound using Lassaigne extract and mention the chemical reactions of the experiment. If sulfur is present in an organic compound, all the sulfur present is converted to sulfide ions inside the Lassaigne extract. Therefore, to check the presence of sulfur, prepare a Lassaigne extract and add a few drops of sodium nitroprusside. This is the chemical reaction for the formation of sodium sulfide. This is the chemical reaction of sodium sulfide with sodium nitroprusside. The final observation of this experiment is a purple color solution. 10th question. Explain the experiment used to identify presence of phosphorus in the organic compound using Lassaigne extract and mention the chemical reactions of the experiment. If phosphorus is present in the organic compound, all the phosphorus is converted to phosphate ions inside the Lassaigne extract. Take a small amount of Lassaigne extract prepared to identify the presence of phosphorus and add a few drops of concentrated nitric acid and a few drops of ammonium molybdate reagent. Then heat the sample. The final observation of this experiment is a yellow color precipitate. This is the chemical reaction of sodium phosphate and ammonium molybdate. This reaction forms ammonium phosphate and sodium molybdate. This is the chemical reaction of sodium molybdate and the nitric acid. This forms molybdic acid and sodium nitrate. Molybdic acid breaks down to form molybdenum trioxide and water. This is the chemical reaction that shows the formation of yellow color precipitate, ammonium phosphate molybdate. 11th question. Explain the experiment used to identify presence of halogens in the organic compound using Lassaigne extract and mention the chemical reactions of the experiment. This experiment is called as the Beilstein test. Take a copper wire mesh and heat the wire mesh using a Bunsen flame until the flame doesn't give a color. Take a small amount of organic compound onto the hot copper wire mesh and again heat it in the Bunsen flame. If halogen is present in the organic compound, the Bunsen flame changes its color to a green color flame due to the formation of copper halides. The final observation of the experiment is a green color Bunsen flame. Some compounds like urea gives the same results to the Beilstein's test. If halogens are present in the organic compound, all the halogens are converted to the halide ions inside the Lassaigne extract. To identify the presence of the halide ions, we can use inorganic tests. Next question. State 3 inorganic experiments used to test the halide ions formed during the above experiment. First one, test using silver nitrate and diluted nitric acid. The solution contains halide ions, is acidified using a few drops of dilute nitric acid, and then a few drops of silver nitrate solution are added. Different colored silver halide precipitates form depending on the halide ion present. Chloride ion forms silver chloride, which is a white precipitate. Bromide ion forms silver bromide, which is a very pale cream precipitate. Iodide ion forms silver iodide, which is a very pale yellow precipitate. And fluoride ion forms no precipitate. The second test is the test using lead nitrate and dilute nitric acid. The solution contains halide ions, is acidified using a few drops of dilute nitric acid and then a few drops of lead nitrate solution is added. Chloride ion forms a lead chloride, which is a white precipitate. This precipitate melts in hot water and recrystallises when cooled. Bromide ion forms lead bromide, which is a cream white precipitate. This precipitate melts in hot water and recrystallises when cooled. Iodide ion forms lead iodide, which is a yellow precipitate. This precipitate melts when boiling and recrystallize when cooled. The third test is the organic layer test. Halide ions are detected by adding excess chlorine water and chloroform in an acidic medium. Question number 13. Is it necessary to perform a Lassaigne fusion test to identify the elements present in ionic or salt form in the organic compounds? The answer is no. When the ions are directly dissolved in water, the ions become aqueous and different reagents can be used to test the following ions.